Sign in. Houston. Okay, I'm trying to bring my iPad down so I can record my my password in my university. Uzi. Just a second. Calling me. Do what's calling me. Just a second. Okay. All right. Meetings 3221. Start. This means being recorded. Yep. Dial in. Call internet. No. Cancel. All right. All right. Excellent. Let's see. Let me see if I can share my iPad now. Share screen. Screen. Start. All right, can everybody see my iPad?
Yep.
Start. Okay. All right. Okay. That's my iPad. Perfect. Right. Welcome, everybody. So today is indeed the last time we will meet as a lecture. I'm planning on going over a final exam from last semester. Just taking a look at the types of questions and what you might want, what you're going to expect, what you should expect from the final exam coming up later next week. So the exam will be available on Monday for a couple of days, I believe like 3 or 4 days. And these are the types of questions that you should expect having. Let's see. It's very much like what you've seen in previous exams. A lot of multiple choice, fill in the blanks. Let's see. There's a question here in the chat. Will this past exam be available on Canvas for later review? You mean the answer? Because I did make the PDF available on Piazza. I posted it earlier today. The recording is being recorded on Zoom and also being recorded on YouTube. I don't know if you mean the actual PDF with the answers. So yeah, no, this is already available. All right. So yeah. So without further ado, let's get to it. Any questions before we get started? Okay. Let me get my iPad here. Let's see if we can make it. Yeah, yeah. No, I don't like that. It's better like that. There we go. Okay. All right, so there's a couple of instructions. You probably have the same exact instructions in the upcoming exam. Please abstain from using extra spaces, any quotation marks, punctuation, unless it's absolutely necessary, right? Unless the question makes no sense if you don't, if it doesn't make sense, the question. I thought the exam opened on Friday. Is that what I said? Okay, sure. I'll if that's what I said, then yes, I'll make it available on Friday, so that you can take a look at it over the weekend. Also, if you If not specified, please answer one blank question. For the blank question, just answer one word per field. Usually my foreign keys have the same name as the primary keys that they refer to, right? Also, I tend to put PK and FK next to each one, so it's labeled and you know what it is, but it's not part of the name of the field, right? It just, the parenthesis just tells you that it's a primary key of a foreign key, but it's not part of the actual name of the field. Also, some nomenclature, right? The A means that this is a table, so that's a table, and these are fields A and C. And if I use this nomenclature, then it means that it doesn't really matter whether it's a string, an integer. It doesn't really matter. Okay. If I need to specify a type, right, there will be an additional colon type 1 colon type 2. If I definitely need to present it. Again, if there's a parentheses with a PK in it, it means that this is that B is a primary key. And if you have an FK, it means that it's a foreign key and is referring to a primary key that has the same name. Okay. Some fields might be both primary key and foreign key. Okay. Also, you might have two fields that both are primary key. So it's a compound primary key. Or sometimes it's also referred to with a squiggly lines, like curly brackets, so that you know that they're collective, where they go together. But I usually don't use the curly brackets. With an arrow, R, and then a arrow means that there's a functional dependency, right? It means that there's a relationship between R and S. Okay. It means that if you know the value of R, you can absolutely know the value of S. Okay. Let's see. It says, can you give a real world example of a combined foreign key, primary key? I remember combined PKs, but not using same field for both. So in an example might be that you might have a car, right? And the car might have primary key model, right? And might have make, right? And they're both primary keys. So the combination of model and make is unique. And so they would both be primary key. And if another table, right, store or something, right, or car store, the car store might have its own fields, and then it might have a foreign key, model, comma, make, right, and these would both be foreign key and foreign key. Right, and they would refer to the same primary key, and that would be from another table. Right, so yeah, you can definitely combine them both. I'm not going to ask you to actually write it out in code, right? It'll probably be some theoretical question about using both. In particular for indexing, those you can ask some really interesting questions about indexing. And when you consider combined or complex keys like this. Also for second normal form, if you remember there's first and second and third normal form. The second normal form, it deals all about compound keys, right? So definitely you should expect questions on that as well. So let me erase all that. There we go. Okay, so right, so this RS R and S means that there's a dependency, meaning that again, if you know the value of R, you definitely know the value of S. Okay, so for instance, an example of that would be that R might be, say, first and last, right? So if you know. So you have two fields. Say you have three fields. Right? and the three fields would be fields first, last, and full. Okay. Well, if you know the first name and you know the last name, well, you definitely know what the full name is, right? Because the full name basically is a concatenation of first and last. Okay, so we say that there's a dependency between first and last with full. Okay, we would write it like this, first, last, right, determines full. Okay, or it'll be explained in English, right? There's a dependency between one or the other, and by dependency means that if you know the value of one, you definitely know the value of the other. And if and if you remember, we had discussed that when you're looking to do normalization, first normal form, second normal form, third normal form, right? And dependencies between the fields is important, right? That we say that we want to make sure that the fields depend on the primary keys, but don't depend on each other. Okay, so there might be some questions about that, right? So if I might tell you, well, there's a dependency between these two fields. Oh, and none of them are primary key or foreign key. Is there a problem? Okay, so if we look at second normal form and third normal form, we say, yeah, yes, definitely there might be a problem. Okay, so anyway, so let's take a look at some of these questions. All right, so consider the following schema, right? So we say that there's a table called A, right, with the two fields, field B, three fields, B, C, and D. Where B is a string, C is a number, and D is a date. Notice that I'm using loosely data types. Okay, so I'm not saying whether this is a UML diagram. I'm not saying this is SQL. It's irrelevant. It's a schema, right? Regardless on the implementation, whether it's JSON or Java or SQL or Mongo, right? It doesn't matter. Remember, the concepts are always the same, right? So given this schema, right, that you have collections and tables and whatnot, right, and you have fields in there, and each field is a different data type, the following questions. Which of the following options retrieves, so which of the following options retrieves documents? Okay, so documents, this must be a non-relational question, right? It's the Mongo kind of a way of storing data, right? Instead of tables, we use documents, right? We use collections. So it says, so how do we retrieve documents whose field is B, right? So we're looking for field B, and it's equal to C. Okay, so it gives you a couple options, and so I guess this is all about just remembering a little bit what the syntax is of the find the various operators, right? In Mongo, right? There are several operators. If you remember, there's a they all have this syntax, right? So db dot, and here's the collection, right? And then dot the operation, and where the operation can be either find, right? Can be insert, can be update, right? And can be delete. Sorry, not remove. Okay, and this is all in the slides, right? And then in the parentheses, you put several the arguments to these things. So this definitely is this is from the Mongo client, right? When you're running the Mongo client and you're using the console to interact with the database, right? So these are all definitely those types of operations, right? So there's a DB, right? There's the DB, then the collection is A, and then there's find, right? And they all have the same. Actually, no, some of them here is find equal. Is find equal one of the valid operations? No, it isn't. Okay, so this is a trick question. So definitely not this one, because this is find equal is not a valid operation. The other ones look okay. Find, excellent. Let's see. So if we remember that all these operations, right? All of these operations are JSON objects that we can provide as parameters, right? And so let's see. So definitely that's a JSON object that we're giving it. That's also JSON object. This one is not a JSON object, right? So definitely not this one, okay? And many of my questions are always going to be like this, right? Two of the options are going to be obviously wrong, right? And you can immediately just discard them, right? The other two is kind of that are left usually is you have to think about it and says, okay, well, is it this or that one, okay? And notice that the only difference here, notice that they all have C at the end, okay? And it looks like the only difference between this and that is that they are switching between these two. See that? Okay, so this is a little bit of memorization, right? And having practiced this over the course of the assignment and whatnot, right? And so what is it, right? But it turns out that all the operations are, when you have when you're doing comparisons, equal, not equal, not, or things like that, right? They take this form, the form of you have the field, right? The operation, and then the parameter, right? So it's this one, right? So it's not it's not this one, right? It's not at the beginning. The equal operator is not at the beginning, but in the middle, right? So it's this one, all right? Okay, I would just go over the syntax. Also, you have plenty of time to go look over your notes. You will have it is open book, so you can take a look at the slides and whatnot. Just be familiar where everything is, so that you can quickly jump and check on your own. All right, so let's keep going. Okay, so this one says fill in the blanks below to complete the code snippet. So it looks like it's giving us two tables, right? Table A and table B, with several fields, right? And looks like so that's the primary key on both, right? That's the primary key on both. They both have this integer. They both have this char. And it looks like A has a date. And it looks like B, right? B has a reference, so that there's a field A, which is a primary key, that is referencing A, is referencing this table. Okay, it's referencing that table. Okay. One thing that might be missing here is that it doesn't say what field it's referencing, but it's implied that it's referencing the primary key of A, obviously. Yes. So what's the question? It says write a SQL query that changes the value of field B in table A. So field B in table A. So A dot B. Okay. Where the value of the primary key, okay, is equal to 234. So must be the value of the primary key of table A, right? So where A dot ID, right, is equal to 234, right? All right. So let's see. We want to we want to update changes, right? I didn't say update. I didn't say update because then the answer would be obvious, right? So basically, we want to update, right? A dot what? A dot B, right? That's what we're changing. A dot B. Oh, sorry. we want to update. Sorry. We want to update A. We want to set B to 123 where, right, A dot ID is equal to 234, right? So then this would be, update, right, set where, right, and that's it. Okay. All right, let's keep going. This says consider the following schema. So again, I think it's probably the same schema as before. So it's table A that has fields B, C, and D, and says, okay, where which of the following options retrieves documents? So that looks like it's a Mongo question, whose field B is equal to C, right? And C is equal to 1, right? So, okay, so if you remember, this could be done two different ways, right? We could use the operation $and, right, with an array, right? And we can say that where B is equal to C, right, comma, right, and then the other one is C is equal to 1, right? Or you could say and, right, parentheses, and you could say, B is $equals, right, C, comma, right, or close it, and then C is equal to 1. Okay, that's one way. Or, right, we could just say that the predicate is just that B is equal to C, comma, right, and then C is equal to 1, right? So so with that knowledge, right, of this couple ways that we know how to do it from memory, let's take a look at the options that they give us, right? So let's see. So already we see that there's a problem with this one, right? Because find takes a JSON object, right? So an object, which is curly brackets, and this one is square brackets. Okay, so that's not going to work. Okay, so that's no good. It's not a JSON object to begin with. So that's a JSON object. These are two JSON objects. Okay. This is a JSON object of JSON objects. That's a string, so definitely not that one. And that's another string, so that's not good, right? So it's between these three. So this one, let's look at this one, right? So if you remember, find has two arguments, right? The first argument is it's kind of like the where clause, right? So where, and the other one is the projection, right? So I think this is trying to trick me into thinking that this is kind of like an and, right? That's saying that B is equal to C and C is equal to 1. So that's a trick, right? So this one is a projection. That's not what we intend to do. So no, that's not that one. So it's between these two. Let's take a look at these two. So this is definitely a JSON object. That's good. Comma, right? Another JSON object with B:C and C:1. That's not quite right. We know that the way this works is that it's going to do a pattern matching of each one of the properties against the value. Over here, this is an object, not a property, right? So what it's really looking for is property value, okay, as opposed to object, right? So this syntax is no good either, right? So definitely the answer is this last one. Okay. All right, so let's keep going. All right, so it looks like it's again on the same table with the same fields, but this time, right, it says which of the following options replaces a document. All right, so it looks like it's still Mongo, whose field B, so where, whose field, so where, right, B is equal to C, so B is equal to C, okay, and we want to replace with a document whose field C is equal to 2, right? We want to replace a document whose field B is equal to C, so that's the where clause, and with a new document whose field C is equal to 2, okay? All right, so let's see. We need to look for this where, right? Where, if you remember, update, right? DB dot collection, and the collection is A, so it would be DB A, and we want to replace a document. So the only way that we know how to replace something is using an update, right? Okay, and the update has two arguments. So the first one is the where, right? And the second argument, right, is the actual update. right? What are we updating? Okay. So let's compare against our options. So it looks like they all are using the correct update, right? So that doesn't give us any clue. Let's see. So this one is doing what? So this one, the first one, remember, is the where clause that says which object, which record are we changing? So that doesn't look like a where clause, right? It looks like it's trying to change something right off the bat in the first argument. So that definitely is no good, right? How about this one? Well, that one's promising. That one also looks like it wants to change something right at the beginning, right? But that's no good right here because this needs to be a where, right? So set looks like it wants to change something, so that's no good. Let's see. So that might, so the where clause is what? Where B is equal to C. Okay, so maybe that one is promising. That's the where. That one is also promising, and that one's promising. Not this one, right? Because that would need to be the where clause. Notice that it flipped it. See that? So that's also a trick question. So that one is no good either. So it's between these three, right? These three over here. So let's see. So they all these three have the correct where clause. We need to now say, well, how is it that we update something? Do we update it using giving an object C:2? Okay. So if you remember, we did it in class, right? Where if we use this option, what it would do is that it would replace the entire object, right? It would throw away the entire object that was there, and you would now get a single. You would get now just a field object that is equal to C:2, right? Any other fields that were there, like B, for instance, B is there, right? You would end up with a new object that did not have B. So it depends. You have to read the question carefully, right? It says replaces a document whose field blah 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 with a new document, right? Replaces it with a brand new document whose field C is equal to 2. So that points to this one, right? That points to that one. Because that's exactly what's happening right here. Is that we're throwing away whatever object you had in there, and now you have a brand new object that has C=2, right? So as the, if you read the question literally, right, then this would be the answer. Another question might have been that says does not replace the document, right? Instead, it only changes the value of the field C, changes it to be the value of 2. If that's the case, then it would not be this one, right? Instead, it would be either between this one and that one, right? Between these two, right? Because it uses the command set, right? And set only modifies the field, that one field. And the syntax is that set comes first, not in the middle. Okay, so this is the field and the value. Set does not go in the middle. Instead, it goes first, right? And then the field and the value, right? So again, if you would have read this and this would have said instead, not a new document, right? But it replaces only, sets it to a new value of 2, then definitely this would have been the answer. Okay, so again, it depends how you read the question or how is it stated, right? And if it's ambiguous and it's not clear, let us know, right? And definitely we will change it and make sure that it is indeed perfectly clear. Okay, so definitely not that one. Okay, so let's keep going. All right, consider this other schema. Excuse me, it's getting really hot in here. I'm gonna just take off my sweater. Just a second. Okay, we're back. All right, so let's keep going. Let's see, we have another schema. We have, looks like we have two tables, table A and F. And A and F looks like it has 2 primary keys, so it's a compound key B and C. And F has a primary key of E Okay, and it looks like A is referencing, right? It's referencing the field E over here. Okay. Okay, so it says if field D has a functional dependencies with field B, okay, but not on C. So that means that D has a functional dependency with field B, right? So so D depends on B, right? So you would write it like this. You say B and D. Okay. What we mean by functional dependency means that if you know the value of B, it's going to be a clue of the value of D. Okay. So for instance, if you know that a car is a Corolla, right? Then you definitely know it's a Toyota, right? Right? Or if you know that a car is a Wrangler or a Bronco, right? Then you know it's a Ford, right? Or a Jeep. Okay. So meaning if you have one of the fields and you know the value of that field, you definitely know some other field, right? It's obvious, and so that has a clue on being some redundancy, right? That you want to make sure you are controlling, you have control over that, right? Because you want to be able to enforce the fact that you don't want bad data, right? You don't want the database to allow you to say things such as, it's a Corolla, right? But then the field make allows you to put Ford, right? That would be a bad data, right? The database should not allow you to do that, right? That if you have a dependency, well, make sure that you can, the database is not going to allow you to do certain things, right? Anyway, so there's a dependency. So there's a dependency between B and D. So D depends on B, but it does not depend on C. It does not depend on C, and that's bad, right? When you have the let's see, when you have, these are non keys, right? D and E are not primary keys. Yes. And so we by normalization rules, right? We remember we have the first normal form, the second normal form, and third normal form. We say that a table is following second normal form if all its fields depend on all the keys, on all the primary keys. And what we're telling you here is that D is only dependent on B, is not dependent on C. So right there, right, it's breaking second normal form, right? Okay. And it's a problem, right? It could lead into inconsistencies, right? And we looked at a couple of examples. We looked at some examples on why that is a problem, right? If you remember, for instance, we had a we had a faculty, or we had the name of a course, right? The name of the course depended on the what was it, on the course ID, right? So you had a course ID, and the course of the name of the course was dependent on the course ID, but the other primary key was the semester, right? So wait a minute, the course doesn't depend on the semester. Who cares what the semester is? The name of the course is always the same name, right? So you do not want to end up with a field such as course name dependent on half of the primary key, right? Because, right, you could, for different combinations of semester and course, you could have different names, right? And that would be inconsistent. Okay, right. So we're already telling you exactly that A is breaking second normal form, right? So 2NF, right? It's breaking it. Okay. All right. So so it depends on B, but not on C. So what normal form is this schema breaking? Okay, well, I just told you, right? We just went over it, right? So it is breaking second normal form. Okay, so there's a little nomenclature to remember, right? Where it says first normal form says that all the so fields must depend on keys, right? And second normal form says that fields depend on the whole key. Okay, and then third normal form says that the fields depend on nothing but the keys. Okay, so basically, you to remember this, it would be it depends on the keys, the whole keys, but nothing but the keys. Okay, so that's one way to remember that it meets all three normal forms. Okay. All right. So next question. So consider the following schema. All right. Looks like it's another Mongo question, right? It says which of the following options includes field B, but not field C or D. Okay, so this is a projection question. And how do you do projection in Mongo, right? And if you remember, the find clause, the find function takes two arguments, right? The first argument, so find takes two arguments. The first one is the where, and the second one is the projection. Okay, so this is a JSON object that has a filter, right? That says, well, which ones are we going to pattern match? And this one, the projection, is also JSON. So both of them are JSON objects, right? And the projection allows you to say things such as, field, field 1 if you want the field, so field 1, field 2 if you want the field 2. If you don't want field 3, then it's a 0, right? And also we need to remember that field underscore ID is special, right? If you don't say anything, then you get the underscore ID. And if you don't want it, you have to explicitly add 0, right? So just remember that. So, okay, with that knowledge, let's go back here. So it's asking us that we want to include B. So definitely we want B, but we don't want C and we don't want D. Okay, so this one is that's no good, right? Because that would be the first object, and that definitely doesn't look like a where clause. Okay. This one says there is no where clause, meaning I'm going to retrieve all the objects, right? All the records, and here's my projection, that I don't want C and I don't want D. Right, but it's not Boolean expressions that we use for this, right? So that's no good. So no and no. This one is not a where clause, so no. So it must be this one, right? C, we don't want C and we don't want D, and we want all the records. So it's this one. Now this one is also going to return the underscore ID, but the question doesn't say anything about underscore ID. Okay, so it should be okay. Right, and notice that includes field B, right? Meaning we didn't say anything here. It doesn't say anything about B, about removing B. So definitely we're going to get B, but we're not going to get C. We're also going to get underscore ID, but the question doesn't say anything about that. All right, let's go next one. So this one is a code snippet A, and B looks like it's A and E, and E looks like it's referencing A over here. All right, so here's two tables, and we're giving you some values for table A and E. We're giving a couple of records. Looks like these 1 and 2, right? These are foreign keys that are referencing these records, right? They're referencing those records because they values 1 and 2. Okay, but looks like this one is a foreign key which is not referencing anything, right? Nothing on table A. So the question says, okay, write a query that results in this answer. Okay. And looks like it gives you a couple hints, right? It looks like it's gonna want to do some kind of join, right, between AID, right? So AID, right, is going to be equal to EA, right? So we're going to join this field with that field, okay? Where so that's the join over here, the join statement over here, and we are selecting A colon C. So this is A dot C and E dot G. So E dot G, right? So these are basically we're grabbing this G, right, and this C. Okay. All right. Looks like we're grabbing all the G's, but looks like we're not grabbing all the C's, right? We're only grabbing just a few C's, but all the G's. Okay. So it looks like we're doing a join between this and this one. If we do a join between this, and it's a natural join, a normal join, right? We would only get these records, only these two records. Okay, because this one, this over here matches with this over here, right? But this one doesn't match with anything over here. It doesn't match. It has no match, right? So if you would only get these two records. So we have a third record there that doesn't match anybody, right? Where this one over here doesn't match anybody. So it looks like we also want that record, even though it doesn't match. Okay, so it's kind of like a natural join, like a regular join, but looks like we want all the records of the table that is on my right, but not all the records that are on my left. Okay. So having said that, looks like we will write something like that. Basically it's probably just a regular join, but we want the right table, and the right table would be depending on how you write this. Okay. So this would be, select A, blah, 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 from, probably this is from A, right? And we're going to, we want to join it. We want to join with E. We have an extra space. So probably, okay, so probably we want, since we also want this last record, right, which comes from the right of our join, right? So this probably is, we want a right join, not a regular join, right? So this would be something like, it would be a right join, with E on AID and EA. Okay, so this would be, from a right join with E. Okay, something like that. All right. Okay, excellent. Let's keep going. Let's see. The next question says, which of the following statements are true? Select all that apply, all of them. So these are check boxes, right? So there might be more than one true statement. Okay. Let's see. It says searching through a table linearly. Okay, so it looks like this is an indexing question, right? So searching through a table linearly, meaning a full scan of the table. Right? Remember that if you have indices on a table, what we're trying to avoid is having to do a full scan, right? That we either going to use those tree structures, right, where we start at the root, right, and then compare the indices left and right, so that we quickly reach the record, right, and then jump to the record ID, right, and then jump directly to where the record is in the original table, right? Or we have a hash table that tells us exactly where the record is, and we can just jump to that table location, right? So all that is to improve the performance of the database searches, right? Where we are avoiding a full linear scan, right? Where we're going exactly one at a time, right? So the question is searching through a table linearly, so full scan, okay, sometimes can perform better than using an index. if you remember that we saw a couple of examples, right, that if your index was a unique index, right, there was a dramatic increase in performance, thousands of times faster if you use unique indices, right? But if we use non-unique indices, we saw that the improvements were not as dramatic, right? And if the data was stored in a particular way and the ratio of how many items, how many records were per the non-unique indices, right? We realized that actually it could be worse, right? And because what we're trying to optimize is how many times we're going to the file system. That's what we're trying to optimize, right? Not the number of comparisons, but how many times we go out to the file system. And we see that for non-unique indices, there could be times where a full scan might be even better than using an index. So yes, sometimes, right? Sometimes, a few times can perform better than indices, and definitely for non-unique. Definitely for non-unique indices, right? So yes, so sometimes yes, this is true. Okay, so searching through a balanced tree doesn't generally perform better than searching through unbalanced trees, right? So if you remember, right, this perhaps, I don't know if you've seen algorithms, but we did discuss this in class, that the trees that we use to store our indices are designed to be balanced, right? That you have the same number of items on either side of the tree, right? As opposed to this being unbalanced, where you might have many more items on one side and than the other. Okay. Now the extremes would be that this is so unbalanced that you just end up with, just all the items listed in a line like that. So you would end up with just basically linear search. Okay. And you have no items on the right-hand side, or the other way around, all on one side skewed all the way on the right and nothing on the left. And so we saw that that the performance of finding something on the tree was proportional to the height of this tree. Okay, so the shallower the tree, the faster the algorithm. So if you allow the tree to be skewed, right, to weigh more on one side than the other, the height was going to be taller, right? The extreme would be when you have all the items all on one left or right side, right, and the height is really tall, and the performance is terrible, right? So yeah, so this is kind of telling you the opposite, right? Searching through a balanced tree doesn't perform better, right? That is not the case, right? So no, right. Definitely you want to keep your trees balanced. So no, that's no good. Then it says indexing always performs better than a full table scan, right? And this is a typo here. Okay, so basically this is saying the opposite of this, right? It's the opposite, so no. We already determined that sometimes it's faster to do a linear search. Okay, so unique indices generally perform better than non-unique indices. Yes, we had the whole discussion. Yes, definitely unique indices can perform thousands of times faster than non-unique indices. So yes, so generally true. None of the options, and that's not good. Okay, so we have two that are true, that one and that one. All right, so let's keep going. So this one says, let me check my time here. Okay, consider the following schema, right? So again, Mongo questions. We want to insert, so create a brand new document where field B is equal to C and field C is equal to 1, right? And we know what the command is. Obviously, it's db insert, and all the options give you the same. So that looks okay. And we just have to remember what is that we give it here as arguments. And usually it's a JSON, the JSON object that you want to insert. Just a quick look at this, right? We realize that this is not a JSON object. It's got these equal signs there. That's definitely not a JSON object. This one has these weird square brackets, so definitely not this one. And this is square, so oops. So this is square brackets, and it has the colon. It's trying to fool you into thinking that this is JSON objects. Definitely not this one. So none of these, right? None of these. And the only one is this one with a proper JSON object. So that one. Oh, this one's also trying to fool you into thinking, see if you remember that what the keyword is, what the command is, and it's definitely not save. Okay, so none of these. Okay, none of these. Create is what we use in Mongoose, right? Mongoose uses the command create, not the command that you use in the Mongo client. And the reason you know this is the Mongo client is because it's got the db dot a, right? That's this gives you the clue. This is the command line that you're actually typing this manually and not through Mongoose. So definitely none of these, because it's got this create here. So it's trying to it's trying to trick you into saying, hey, I remember a create, but remember that's on the Mongoose side, not on the Mongo client, right? So definitely the answer is this one over here. Okay. The next one says, fill in the blanks below to complete the code snippet. Consider the following schema. So we got the same tables as before. We have A and F, and we have this E referencing this E over here. Okay. So create an index. So create an index that can improve the performance of the following query. All right. So let's look at this query. So it says here that we want to select from the table A. So the index has to be on table A, where C is equal to D, E, F, and D is equal to 1, 2, 3. Okay. The challenge here is that there's an and there. See that and over there? So that means that if you remember when we were working on composite keys, if you had the indices on C and D, and then you had the values of C and D, right? And when you wanted to search on two fields, it was a good idea to create a composite index on both fields. Okay, in that order, right? In that order. Well, in the order depending on your query, right? So say if you're always going to search on C and on D, notice that we don't have any other queries. The only one we can go by is this one query. So if we only consider this one query, we can improve the performance by creating a composite index on both C and D, right? So we can implement that by saying we want to create an index, right? My index on the table A on both fields C and D. Okay, C and D, right? So if we fill that in, this would be create index on A with composite index. Wait, do I have 5? So this is C and D. Okay. All right. Okay. All right, so let's keep going. Let's see. So consider the following schema. So same table as before, right? We have E as a foreign key that's referencing E over here. And it says that the initial value of C, right, for a given record is 20. So, okay, so we have a record. We have one record, right, where the value of C is 20. Okay, some record in table A. So this is on table A. Okay. So let's see. What would be the risk? What is the risk of the following sequence of events? Okay, so it looks like we are looking at transactions. So remember, there were, what was it, three different things that could go wrong, right, in a transaction. Right? We said that there was a phantom read. Sorry, a dirty read. So there was a dirty read. There was a non-repeatable read, non-repeatable read. So these are the three things that could go wrong, and a phantom read. Okay. So those are the three risks, right? Those are the three risks that we run into. So it's asking us, okay, these are the sequence of events. We have transaction A. So transaction A is reading from A, and where B is equal to 1, 2, 3, right? And presumably they get a value of C of 20. So presumably, they get C equal to 20. Okay. Then comes in transaction 2. Transaction 2, in between. Okay, notice that it looks like there's two select statements. So it looks like it's reading twice. Okay, it's reading once, and then it's going to read again. All right, but in between, there's somebody went in there and sneaked in an update, right? And they changed the value of C to be 19, where B is 1, 2, 3. So it's changing the same record that this transaction is reading, right? So when you read it here, you get C 20, and when you read it here, you get C is equal to 19. So whoever's issuing these commands, right, they're going to scratch their heads and say, wait, what the heck happened to the value of C? How did it change? I didn't change it. Who changed it? But remember, transactions are unaware of each other, right? And so we need some kind of protocol, right, to make sure that each one can work in isolation, right? And if you remember, there were 4 isolation levels, and each isolation level dealt with a different type of risk, right? We saw a read committed. So we saw read uncommitted, read committed, repeatable read, and serializable, right? Those were the 4 isolation levels, and each one deals with a different type of risk. Okay. But here they're not saying anything about any of the isolation levels. They're just saying, hey, these are 2 transactions are running. What could go wrong? A dirty read, a non-repeatable read, or a phantom read. So if you remember, phantom reads is all about, I do a select on a range and I get a whole bunch of records, and then somebody comes in and inserts or deletes one of those records that I just read in, right, like a range. So that if I run the range again, the query, then where I used to have 10 records before, now all of a sudden I have 9 records, right, or have 11 records. So somehow there's a new record that was not there, right? So phantom reads deal with adding and removing whole records, whereas dirty reads and non-repeatable reads deal with individual fields in a particular record. Okay, so definitely. Here, it doesn't look like we are looking at selecting ranges or inserting or deleting a whole record. So it looks like definitely not this one, not number 3. So then we look at what the logic here seems to be is that I read it once and then I read it again, right? And then it looks like I'm looking at these values. And my depending on how my logic is, obviously I don't have the source code of what folks are doing with this, right? Is that the value of C might have changed, right, between when you read it the first time and when you read it the second time, right? So that's a classical non-repeatable read, right? That I read it twice and I get 2 different values for each one, right? If I want to guarantee that this is not going to happen, I can start an isolation level at the beginning and say, hey, I want a repeatable read isolation level, and that would guarantee that I would see the value of C not change on me, right? Even if somebody come in here and tries to update, they would be put in a queue, right, having to wait until I do my commit, right? And then they would come in and be allowed to change it. But looks like they were able to come in, change it, right? And the value is 20. So the problem here is repeatable read. Okay, that's the risk. Also notice the question here is trying to trick you. It has a mixture of risks, right? So that's a risk, right? Repeatable read, dirty reads, and repeatable read, and oops, sorry, no, repeatable, non-repeatable read, that one, sorry. Yeah, so I was confused too. So some of these are isolation levels, and some of these are risks. Okay, so read committed is an isolation level. So it's an isolation level. Serializable is an isolation level. Okay, repeatable read is also an isolation level. Okay, risks, right, are this one right here. So this one is a risk. This one is a risk, right? And that one's another risk. So notice that I'm trying to confuse you so that you know what the terminologies are, and so that you remember which one is which. So there's a table on the slides that clearly identifies what are the risks, right, and what the isolation levels are, and what risk is fixed by which isolation level, right? So please either memorize the table or just be familiar where that table is in the slide, so you can quickly go in there and retrieve it. Okay, so yeah, so non-repeatable risk is the risk, because it's asking us about the risk. What is the risk? Okay. All right, so question 12. Fill in the blanks below to complete the code, the snippet, and only use blah, 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 blah. Okay, so we're giving a big table here. The table is the employee table, and it's got a whole bunch of fields, right? It's got a primary key, right? It's got a start date, first, last, department, and salary. So the question is, write a SQL query that calculates the average salary per department, okay? So meaning by this, we're gonna have to group by that field, right? So there must be some kind of group by department, okay? Notice that it gives us a hint of where we have a by there, right? So that's kind of telling us that right already this should be something like group, right, by department. Okay. Also says that we want to calculate the average salary, right? So basically we want to average out, we want to average the salary. Okay, and we're going to name it average starting salary per department. Okay. All right, another Mongo question. All right, so notice that the exam will be somewhat heavier on the second half of the semester. Right, a lot of Mongo questions, and transaction questions, indexing questions. So let's see. So which of the following? So we have collection A with a B is a string, C is a number, and D is a date. Which one of the next retrieves documents whose field B is equal to C? Right. Again, asking you whether you know your syntax of your finder. So let's see. Again, right? We want JSON objects. That's not a JSON object. That's not a JSON object. That's not a JSON object. So it's between this one and that one, right? Following retrieves whose B is equal to C. B is equal to C. So yeah, so it must be this one, right? It must be that one. So it's that one. Okay, again, that one is not a JSON object, so we can quickly eliminate those. Right. Consider the following schema. Again, same schema. Which of the following objects includes fields B and no other? No other. Right? That one's kind of a hint that, whether you remember that the underscore ID field is included by default, right? If you don't say anything, the underscore ID will be included. But here, if we are explicitly telling you, we don't want any other field, right? So be careful, right? So choose the best option, okay? So yeah, so this one right here would work, right? We get the B, and we don't get any other field, but you would still get the underscore ID, right? Because we don't explicitly remove it, right? So this one's no good, right? This one looks like, so this is kind of tricking you, right? It says, yes, I want the B, and I don't want the ID. The problem with this, right, is that you remember the syntax of find. the syntax is fine is that you first have the where clause and then you have the projection, right? So this one is kind of like forgot the where clause, right? So this one's no good. Again, same thing. They're just trying to trick you into thinking that you're going to forget that you want the where clause first, so that's no good either. So by elimination, you definitely get this one right, where you're saying you're getting all the records. Yep, I want all the records. I want B, and I do not want ID. Okay, so definitely it's that one. All right, so fill in the blanks to complete the snippet, blah, blah, blah. Okay, so this question is about Mongoose, right? Mongoose model. The model is called a model, okay? Created from the following Mongoose schema. So we're giving you the schema, Okay, so retrieve all documents whose field B is equal to C, okay? So find all documents. So remember, Mongoose has a couple of finder methods, right? It has a dot find, right? That returns an array. It also has a find one, right? Where you give it an object of some field is equal to some value. So that returns, this returns an object, a single object, and you have find by ID, right? And here you just provide the ID, some ID, and it returns a single object. Okay. All right. So, but this says that it wants all the objects. That means all the documents. So that means that it can't be this any one of these two. It has to be find. Right? It has to be find because you want an array, right? So a model. So that's a find. And where B is equal to C, right? So we know that, right? This uses the same exact syntax for the where clause here, right? So this would be B is equal to C, right? So this would be find B and C. All right, so fill in the blanks below to complete this code snippet, blah, blah, blah. All right, again, we have the same Mongoose model. And this one says update a document whose field C is set to C. So B is equal to C. Modify only field C. So careful, we don't want to replace the whole object. We just want to replace that one field. We want to change it to 2, 3, 4. And this is kind of asking you, do you remember that there's a difference, right? If you don't use the $set, right, it's going to change the entire object. Here, we're telling you explicitly that we want to change a single field, right? So you need to remember that we need to use the $set, okay? Right, so remember that the command on a Mongoose model to change something is the update, right, where it takes 2 arguments. The first argument is the where, and then the second one is the actual setting or updating. All right, the update command, right? So the where clause is what? Is where B is equal to C, right? So this is easy. So it's B, and then C here. And then again, because we want to change a single field, right? We need to use the $set command, right? And we want to change C. We want to change it to the value 2, 3, 4. Okay, right. So this would be update, B, where is equal to C, and we're going to do $set C to 2, 3, 4. Okay. All right. Let's keep going. So it looks like we have another Mongoose question. So they're asking us to create a new schema with a field called C, which is a number, right? Okay. So if you remember the syntax, right, which you must have written it to complete your assignment, right? We know that here we are importing Mongoose, so definitely we have here Mongoose, right? And this one here is schema. Okay. and we want a field called C of type number. Okay. And so this is Mongoose, right? Schema, C and number. All right, so another schema. Which of the following options deletes a document whose field B is equal to C? Okay, so so this kind of you know checking to see if you remember what command do we use at the command line DB. See that DB? So this is at the using the Mongo client, and definitely it's not delete, right? And definitely it's not retrieve and then remove, or retrieve and then delete, right? Definitely it's not that. So obviously we're left with the remove, which is the correct, right? And B is equal to C. So it's that one. Consider another schema. We have A, same schema as before, right? Where E is referencing this F here. And we get another transaction. And so in this, we have a couple of transactions. So in this transaction, looks like in C starts off with 20. So same thing as before. We're asking what would be the risk? Okay. So it looks here that we are reading from table A, right? And we're looking for B is equal to 1, 2, 3, and returns the value of C is equal to 20. Okay. Now, meanwhile, we are going to change the value of C to 19. We're going to set the value of 19 of the same record, right? This is the same record that we're reading from. Okay. Now notice that I then do another call and read the value. I read the value and it's 19. Okay, but notice that notice that I am reading something that has not yet committed. There's no commit here. See that? There's no commit. And notice that right after I read this to be 19, I roll back. That means that I was reading the value of C before it had settled to be actually the value. And actually, we threw it away. Our changes were thrown away. So I read the value when it had not yet settled, right? And not yet committed, right? And so that is if you use the isolation, when you don't use any isolation level, right? When you use read uncommitted, right? You are reading data when it's not committed, right? And that gives way to the risk of dirty reads. Remember, there's 3 risks: dirty read, and non-repeatable reads, and phantom reads, right? So in this case, I am reading something that has not yet committed and actually it's being rolled back. So definitely you are looking at a dirty read risk. You're reading things that are still uncommitted. Okay, so here's another Mongo question, right? Same schema from before. Which of the following options retrieves documents whose C is greater than 1? So this is again checking to see if you remember the lecture from Mongo when we were looking for seats or courses with values that were greater than. Okay, looks like they definitely it's MongoDB, right? And they're all using fine except this one, right? And there's no such thing as greater with a Q, right? Definitely not that one. Definitely not a string, right? So fine definitely doesn't use string. So none of those two. How about this one? These two. Looks like the only difference between these two is that they are switching the command greater than with the value. So which one would it be? Right. So again, this is checking to if you remember that syntax, and the syntax is that comparisons, right? Comparisons go in the middle, right? So here you can say there's greater than, right? There's a whole bunch of them, right? There's a equal, right? There's less than, there is greater than or equal. There's also less than or equal, right? There's not equal, Okay, and there's also in. You should be familiar, in general with all these operators. And so definitely it's this one. Okay. Let's see, question 31. It says, find, fill in the blanks, blah, blah, blah. We're asking you, looks like they want us to create a schema with a field called B of type string that stores its documents in a collection called A, right? Yeah, so we want to create a, so this would be Mongoose, right? So Mongoose here, and then here would be schema, right? And B says B is a string, right? It's a string, so here you have a string, right? And that the collection is called A. So this is this would say collection, and this would be A. Okay. So fill in the blanks to complete the code snippet below, blah, blah, blah. So consider the following data model. So we have a class A, we have a class W, and looks like A has 3 fields, and W also has 3 fields. Looks like W also has a star on its side, so it's on the weak side, and 1 is on the strong side, right? That means that there's a one to many. So one, oops. So one to many. And usually the way we implement that is that on the W side, we would have some kind of foreign key that references back to the parent. Anyway, so how this says, write a SQL statement that creates an equivalent relational model. Okay, so it looks like we are implementing table A for you with a field's ID that is not, notice that ID is not listed in the class, which makes sense. It's okay, right? In UML, typically we don't list the primary keys. That's okay, right? But we have fields B, C, and D, right? That match the correct data types here. And then we start off with W, right? The table W, and start off with fields X, Y, and Z, right? That match the names and also the data types. We do have we notice that we have a field here, AID, right? We're declaring as an integer. Notice that we're giving you a hint. Oops. Notice that we're giving you a hint here that it has something to do with A and it has something to do with the ID in A, right? And yes, I mean, we do have to implement the one-to-many. And usually the way we implement is that we have a foreign key on the weak side that references the strong side, okay? So there it is. So we notice that we have field AID that's declared here. And usually that's going to reference, right? So we can write that, right? This is a foreign key AID that references, right? Table A field ID, okay? All right, so fill in the blanks below to complete the code. So declare a Mongoose schema with a field called C of type number with a default value of 2, okay? So the syntax is that this would be Mongoose, and this is schema, like we just did earlier, right? And the field C is number. Oh, there's a typo here, right? There's a typo. Anyway, if there were no typo, it would read as C is a number, and the default value is 2, and so it would be default 2. The correct syntax is actually as follows, right? So is so this would be C colon, and this would be type number, comma, and this would have default colon 2, like that. That's correct. That's the correct syntax. Nevertheless, you should be able to figure that out, right? Of what I meant. Fill in the blanks. What does SQL stand for? Right. Well, you can look that up. Fill in the blanks below to complete blah, blah, blah. So Mongoose schema that declares D with of type date. Yeah, required D. So D of type date. And okay, I think there's a typo here as well. I think this was supposed to say with default value of current time. I think that's what it was supposed to say, right? I'll fix that. So yeah, so again, so this would say default, and the value for this would be the object date, the JavaScript object date dot now. So now is a function, right? It's a function that default can use to invoke this function now, right? To calculate what the current value is for the field D. Okay. Yeah, you can use this as a benchmark to answer these kinds of questions. All right, so here's another model. A Mongoose model created from the following, blah, blah, blah. All right, so that's the schema. Retrieve a single document whose primary key is ABC. So it's a single document, careful, right? Single document. Remember, there's a few finders, right? Find does not return a single document. This returns an array. The only two that return one document is find one, right? And find by ID. Only those return a single document. Right, so definitely not that one. And so this would be a model. So this, since we are doing a by primary key equal to ABC, and notice that here, right, we can just type the value ABC. Obviously, this is ABC, right? ABC. Then this one needs to be find by ID. Okay. If the question would have been something like a model, so a model, right, and blank. Wait a minute. This would have said, blank, and this would have said ID. Oops. Okay. Blank. Like that. Then the answer would have been find one. Right? Again, because this says a single document. If you use find, then you would return an array, not a single document, right? And then we would have said ID, and this is what is it? ABC. Okay, so these two are equivalent, but they take different arguments. This one takes the actual ID as an argument, whereas this one takes in a object that can be used for a filter, right? And this is useful. Obviously, you can do it for the ID, but it's useful if you know that the field here, right, is unique. You can find maybe by, find by username, which it's unique, and then the username, username is unique, or email maybe also. Email, also is unique. Right, those are useful for querying things that have to do with one unique fields. How do you make a field as required in Mongoose? Yeah, so for instance here, right, in where we had this over here, where was it? Where they had the schema here, right? This default. So when you use this syntax, of declaring a field of a particular type like this, right? This allows you to have defaults. It allows you to have things such as also excuse me. It allows you to have things such as also required true. Okay, it allows you to also, right, if this were a string, right, if this were a string, we can say role. You can say that type is string, and you can give it a default. And by default, you are a student, maybe, right? And you can give it an enumerated data type. You can say enum, and you can provide values, valid values such as admin. What else? Faculty, student. Okay, that's when you use this syntax of giving the, as opposed to just saying role :string. Right? If you use this syntax, then you can't use any of these additional configurations, right? But if you use this syntax where you give the type of string, right, then you can use all these additional configurations, which is pretty cool. Okay, so let's keep going. So this one says, fill in the blanks below to complete this code snippet, blah, blah, blah. Given Mongoose a model, create a model created with the following Mongoose schema, right? There's the schema. Create a new document whose field B is set to C and C is equal to 1, 2, 3. Okay, so this is kind of trying to see if you remember that in Mongo, right? If you're using Mongo at the command line, you use insert, right? You say db dot sorry, you say db dot collection, right? Dot insert. But in Mongoose, we don't use insert. We use instead create. Right? It's create. Create issues an insert. Okay, so this is a slightly different thing there, right? So yeah, B is equal to C, and the field C is equal to 1, 2, 3. Right? So there you go. Let's see. So consider the following schema. So same schema we've been using all along, right? It's E is referencing this over here. If field D has a functional dependency on field E, so D has a functional dependency on E, meaning if you know E, you know D, right? So if you know E, you know D. Okay. So an example of this is, if you know that the faculty is Einstein, you know that they are teaching physics, right? Or if you know that the model is Corolla, right, then you absolutely know that this is a Toyota. Okay, so these would be two fields that depend on each other. But right, so D depends on E, but not on B or C. Sorry. So it does not. So D does not depend on C, and it does not depend on B. Okay. So what this is what normal form is this breaking? Right. Yeah. So remember the mantra, right? It says first normal form has to depend on the key, the whole key, and nothing but the key, right? Okay. So well, definitely is not complying with it's not depending on the key, definitely, right? Definitely not depending on the key. It's breaking that one. It definitely is not depending on the whole key. And nothing but the key means are you depending on something else that is not the key? Which is indeed the case, right? We have a dependency on something else that is not the key, right? So so definitely is not compliant with normal form 3. We also, when we covered this, we said that they, if you complied with a higher level of normalization, you would say that you complied also with the lower ones, meaning that if you comply with 3, well, you definitely comply with 2, and you definitely comply with 1. If you comply with 2, then you definitely comply with 1, but not necessarily with 3, right? So meaning, if you comply with 1, not necessarily are you complying with 2. But if you're complying with 2, you definitely are complying with 1, but not necessarily complying with 3. So complying with the normal form, right, doesn't mean that you are also complying with the one above, but you're definitely complying with the one below. Get it? Okay. So since you're not complying with 3, obviously you're not complying with any one of the 3, right? But so we're looking to see which one of the highest normalization are you not complying, right? In this case, it's number 3. So 3 is the one the highest normalization that you're not complying, and obviously none of the ones below, right? By definition. Okay. So fill in the blanks below to complete the code snippet, blah, blah, blah. Given the Mongoose model, a model, created blah, blah, blah with this schema, retrieve a single document whose field C is equal to, okay, so single document, right? So definitely either find by ID or find one. So definitely not find. Now, find by ID would be, you could use find by ID, but find by ID takes a single argument that is not a JSON object, right? It's a value that gets compared against the underscore ID. Here, we're giving an object. We're giving an object with some property and some value. So definitely it's not find by ID. It's definitely not find because we want just a single document. So it has to be, right? It has to be find one. Okay. And C is equal to 2, 3, 4. So C, right, is equal to 2, 3, 4. Okay. Let's see what else we got here. So consider the following schema. Yada yada yada. This schema and the so which of the following options updates a document whose B is C and modifies only field C to a new value of 2. Okay. All right. Let's see. So update. Looks like they're all using update correctly. Okay. And if you remember all the update commands, the first argument, right? The first argument is supposed to be a where, right? And the second argument is supposed to be the actual update. Okay. So let's see. So well, definitely not this one, right? Because it looks like this one is updating it as the first argument. So definitely not that one. And definitely not that one either. Okay. Let's see. So this one looks like it's doing the pattern matching correctly, right? So all of these seems to be doing the pattern matching correctly. This one seems to be doing it backwards, right? So that one's not it. Let's see. So this one, remember that this replaces the entire object, right, with a brand new object of C equal to. So that's not what we want either. Okay. And so it's left between these two here, right? And this one, just asks you whether you remember, right, the order in which you use the $ set, right? Either is, whether it's before or at or in between, okay? And we know that the syntax is that it's first, not in between. Okay, so definitely it's this one. Let's see, fill in the blanks below to complete the code snippet. Only use lowercase, blah, blah, blah. Okay, so Mongoose schema. So we're going to create a schema with a field called B whose type is string. So it's a simple one, right? So we want to, Mongoose schema with a field B is string. Okay, so we're giving you a data model A. And we want you to create a SQL statement that creates the equivalent relational model, right? So So something like create, presumably create table A, and the fields is B, B, C. So B needs to be an integer, right? So this could be int. C is this one is a string, so this should be a varchar. And finally, D is of type date, right? So that's D over here. Okay. All right, so fill in the blanks, blah, blah, blah. It's a Mongoose schema. So create a Mongoose schema with a field B of type string whose only valid values are A, B, and C. Okay. So yeah, so we want to say that we want to create a Mongoose schema with field B. So field B, B, so B, so we said where it's, why am I, all these have, they're missing a couple of things. So yeah, so this B, and so this would be an enum. So this is just asking you to see if you remember that keyword enum. Okay. Consider the following schema, blah, 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 which of the following options only, blah, 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 includes fields B, C, but not D, right? So, so definitely not the true, right? No true anywhere. There's no such thing as a projection, right? We said we have B and C, but not D. So B, C, but not D. It doesn't say anything about underscore ID, right? So definitely not this one. So that one, okay? And I guess let's do one more. Consider the following, blah, blah, blah. We have that schema. Which of the following documents retrieves by its primary key? Okay. So first of all, find by ID and find by ID, those are not valid Mongo queries, right? That's Mongoose, not Mongo, not Mongo client. Okay, so these are definitely Mongo, right? So that is wrong, right? Because the collection comes after the DB. Okay, that was wrong too. So it's between those three. So definitely not this, not this, and not that. Definitely not that. So it has to be this one, right? So it's find where B is by ABC. Okay. Oh, wait a minute. We got more. Wait a minute. So this one. So B is not the primary key. So this cannot be, right? Yeah. So there's ID. There's ID, right? And where object ID is ABC, and so definitely it's that one. All right, folks. We ran out of time. I need to prepare for the next lecture. And so this is available to you on Google, YouTube. I mean on YouTube, and also should be available on Canvas. And this PDF has been linked on Piazza, so take a look at that over there. All right, folks. Thank you so much. It was great. A lot of fun. And good luck finishing off your project and with the end of the semester. Take care.
Thank you.
Thank you.
Bye-bye.